All right, welcome to video 5, the answer key for problems number 12 and 13 for the summer homework packet. All right, in problem A, what we're doing is we are solving a quadratic equation, and that means we have a polynomial of degree 2, and it's set equal to 0 already for us, and we could perhaps try factoring this or use completing the square. I think for this time what I'm going to use is the quadratic formula, and as a reminder that's negative b plus or minus the square root of b squared minus 4ac all over 2a, and that is equal to the x values, that's 0, the expression. So let's go ahead and start plugging in numbers. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And if we start to simplify this down, we'll get negative 12 plus or minus the square root of 144 minus 4 times 4 times 3. So 144 minus 48, and that is all over 8. And that 144 minus 48 is going to be 96. And so we have that answer, negative 12 plus or minus the square root of 96. And we might see if there's any common or any factor we can pull out of the 96, any perfect square. And 96 is divisible by 16, so let's go and pull a 16 out. The square root of 16 is 4, and it's 16 times 6 is 96, all over 8. And if we want to take that value and reduce it, we will get x is equal to, looks like all three of them are divisible by 4, so we'll do negative 3 plus or minus the square root of 6 over 2. And look at that, it's an irrational answer, so I would not have been able to factor it. Okay, for 12b, looks like what we have here is 2x plus 1 is equal to 5 over x plus 2. And we're trying to solve this. I'm going to get rid of my fractions by multiplying everything by x plus 2. And I have to remember that when I do that, negative 2 is still not in the domain of the function. So if I get negative 2 as an answer, we need to pull that one out of our answers. So we can distribute this and get 2x squared plus 4x plus 1x plus 2 is equal to 5, and 2x squared plus 5x minus 3 is equal to 0. There we've reduced it to a quadratic, and again I'm going to go ahead and use the quadratic formula for solving this one. So we get negative b plus or minus b squared minus 4ac all over 2a. In this case, that reduces to negative 5 plus or minus 1 over 4. So negative 5 plus 1 is negative 4, so we get the answer of negative 1, and we get the answer of, what is that, negative 3 halves. So there's our two values. Double check it against the domain up here. We were only restricted in the sense that we could not use negative 2, so we're good. These are our final answers. Okay, in 12c we are adding two rational functions. So the rational function x plus 1 over x, and we're adding to that, or I guess you could say subtracting x over x plus 1. We're going to set that equal to 0. So what I'm going to do is multiply out the denominators to get rid of the denominators, keeping in mind x cannot be 0 and x cannot be -1, because that would give us a 0 in the denominator. So if I multiply everything by x, I'm going to have x plus 1, x plus 1 equals, minus x squared over x plus 1 equals 0. And then we'll multiply everything by x plus 1. So we get x plus 1 times x plus 1 minus x squared is equal to 0. If we go through the process of distributing, we'll get x squared plus 2x plus 1, subtract x squared equals 0. Our x squareds cancel, and we're left with the expression 2x plus 1 is equal to 0, or x is equal to -1/2. And that doesn't constrict or conflict with either of our domain restrictions, so we're good there. Those are our two answers. Rolling on to our next problem, number 13a. Right, in 13a we are given a polynomial of degree 3, and we're also told that it has a solution of x equals 2. And we're asked to find all the other solutions. So because it has a solution of 2, we know that it's divisible by x minus 2. So we'll go ahead and do synthetic division to divide out that x minus 2. The 12 comes down. 12 times 2 is 24. Add those two values. 1 times 2 is 2. Add those two values, and -1 times 2 is 2, -2. And add those two values, and we get the value of 0. So because this value is 0, it confirms that 2 is a solution to that polynomial. So now what we have is 12x squared plus x minus 1, and we're trying to find when is that equal to 0. So we'll just go and use the quadratic formula here and see what we can pull out here. We get negative b plus or minus the square root of b squared minus 4ac all over 2a, which is the same thing as -1 plus or minus 7 over 24. So -1 plus 7 is 6 24ths, or -8 24ths. Those are our two solutions. So all of our solutions are x equals 2, 1/4, or -1/3. So those are the three solutions to this polynomial. In other words, if we plugged any one of those three numbers in, we're going to get an answer of 0. Okay, 13b, we're doing the same thing, except they don't tell us any of the solutions. They give us the equation 12x cubed plus 8x squared minus x minus 1, and they tell us that all the solutions are rational and between plus and minus 1. So this is a rational root theorem. We write out all of the factors of the last term, which are just 1, and all of the factors of the first term, which would be 1, 12, 2, 6, 3, and 4. And so those are all of our possible answers, and we can test them out to see which ones work. And so I'm going to first start with positive 1. I could do any of them. Positive 1, 1/12, 1/2, 1/6. Any of them will work. But what I want to do is test to see if one of them does equal to 0. Because as soon as it does make the equation equal to 0, I know that's a root. So let's try positive 1, and we get 12 plus 8 is 20 minus 1 minus 1. And that doesn't equal 0. So we know 1 doesn't work. Let's try negative 1. Negative 1, 8 times negative 1 minus negative 1 minus 1. And we get negative 12 minus 8 is negative 20. And again, that doesn't equal 0. So let's move on to the next one, maybe 1/2. So 1/2 in here, 8 times negative 1, or positive 1/2, minus 1/2 minus 1, and again this doesn't equal 0. And this is when I start to think looking at a graphing screen can help you narrow this down, and we're relying on a calculator. Fortunately, by the time I get to the negative 1/2, I find that that does equal 0. So I know negative 1/2 is an answer. So let's take that fact and apply that to our synthetic division. We can put in, since negative 1/2 is an answer, we can put negative 1/2 in the box and then do some synthetic division. 12 comes down. 12 times negative 1/2 is negative 6. 2 times negative 1/2 is negative 1. All right, there we go. Now we're at 12x squared plus 2x minus 2. And we're finding when is that equal to 0. And let's go and factor a 2 out to deal with smaller numbers. And now we've got a quadratic equation. Let's apply the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So we get negative 1 plus or minus 5 over 12. So our final solution is x is equal to negative 1/2, which we found using the rational root theorem. And we also have x equals negative 4/12, positive 4/12 actually, or x is negative 6/12. And reducing those fractions, we get 1/3 and negative 1/2. So it looks like the function has a multiplicity of 2 at negative 1/2, which means my curve should come up and touch negative 1/2 and then cross again at 1/3. And checking that out on the calculator, I see that the calculator does confirm our findings.